Hello, everyone. My name is Prof Pillay, and I shall be conducting sessions to unpack the Olympiad competitions that are administered by the South African Mathematics Foundation, to whom we are very grateful for managing these recordings. More specifically, we shall be looking at the 2023, 2024, 2025 junior papers and senior, as well as the team competitions, and through the various rounds, but actually starting from round 2 to round 3. So without much further ado, we will go on to what we are going to discuss today, and that is the 2023 round 3 junior paper. All right, let's go straight to the matter at hand. And we want to go to question 1. Or actually, it starts from question 2. I suppose question 1 was too trivial. All right, so this is the question. Consider the cube given alongside. Show how to place the numbers 1 to 8 at the vertices of the cube. All right, so the vertices, there are 4 vertices at the top and 4 vertices at the bottom, making 8 vertices altogether. So these are the vertices that are referred to in this question. You want to place them from 1 to 8 so that the sum of the 4 numbers at the corners of each of the face of the cubes are the same. In other words, when I add those top 4 numbers, it'll be the same as the bottom 4 numbers. It'll be the same as these side numbers. It'll be the same as those. In fact, there are 6 faces altogether, and in each face there are 4 vertices, and these 4 vertices are supposed to be add up to the same quantity. Like the sum of the 4 numbers, they all are the same. Okay, now you've got the numbers going from 1 to 9 or 1 to 8. So let's just first add all these numbers to get some sense as to how to proceed from here. When you add these, you get 36. All right, so the 8 numbers add up to 36, but each face is the same sum. So therefore, A plus B plus C, if you look at the top face, is the same as the bottom face. That's given, the sum, so the same. But these two add up to 36. So each will have to be 18. So these 4 numbers, those 4 numbers add up to 18. All right. So now, if these numbers and those 2 numbers add up to 18, and these 2 also add up to 18, it means that the sum of these 2, A plus D, right, plus this is 18, and this plus that is 18. So this sum is equal to this sum here. So likewise, this sum here, if you go down the face, will be the same as this sum. And this vertical sum here, for instance, is the same as the vertical sum here. So you get quite a few like that. All right, what I'm going to do is these numbers are, they're not repeated. It says that all these numbers are placed at the vertices. Yeah, I think it was said that they are not repeated. So what do we have here? I just want to look at, for instance, the pair AD. We'll take the pair A plus D, that one, and C plus B plus C. Okay, now the four numbers add up to 18. So you could have 117, 216, 315, 414, 513, 6, 12, 7, 11, and so on. But we can eliminate all these guys here because you only got the numbers from 1 to 8. So we no, I'm sorry. These are not eliminated. Okay. We got A plus D. The sum of these numbers is that. Okay. Now let's have a look at this. 17 can B plus C can be equal to A plus 17? Then it means the only way you can get is 8 and 9. So that can be taken out. Okay. Because 9 is not present here. Here, 16, again, you'll have 9 plus 7 or 8 plus 8. You're not allowed to have 8 plus 8 because the numbers are not repeated. B and C can't be 8 and 8. So we can take this out. Okay. Now, 3, A plus D is equal to 3 means that A and D are 1 and 2. So you got 1 and 2 there. And so these two numbers will add up to 15. Now, if this is 1 and 2 adding up to 3, then this will also add up to 3. But there's only one way to add up to 3. That's 1 plus 2. So you can't have this adding to 3 because that sum will be the same as this sum, right? This line here is common. And so that's out. The 3 is also out. So I'll eliminate this. And 4, can you have A plus D is equal to 4? Again, you'll have the only way you can have it is 1 plus 3 and 2 plus 2. And 2 plus 2 is not allowed. So we can take that out as well. Okay. So the next one is 513. So let's look at 513. So 513, you can have two ways. You could have 1, 4. And here at the bottom, you're going to have 1 plus 4 is 5. So this sum is also 5. So it has to be 2, 3. Okay, the only thing is I don't know whether it's 3, 2 or 2, 3. That we'll have to work it out by trial and error. So you got 5 here. So these two add up to 8, 13. All right, so how can they add up to 13? So CB, so if AD, let's take the spare. If that is 1, 4, then you have the BC. All right, so these two add up to 5, and these two add up to 13. So B can start from, you can't have 4 and 9, but you can have 5 and 8. or you can have 6 and 7. Those are the only possibilities. Let's try 5 and 8. All right, so you get 1, 4, 5, 8, and this is 2, 3. Now, if you got 5 and 8, you got 8 plus 2 is 10, 13, 18. Okay, that's fine. Okay, this works out well. And now, what about this? 4 plus 8 is 12. So these two add up to 6. Now, how do you get 6? You can get 6 by having uh, 1 and 5, but 5 is already in, so that's out. You can have 2 and 4. 4 is already in, or you could have 3 and 3. So this can't be filled. 1 plus 5 is 6. You can't get 2 plus 4 or 3 plus 3. So this possibility is out. Okay, so you don't have 1, 4, 5, 8. Or unless you switch these around. Why don't we switch these around and make this 8, 5? You can do that. Then you might have a different setup. So if I put an 8 there, instead of putting 8, 5, I could have put 5, 8. It still add up to 13. And this one here will still add up to 18. But the nice thing about this is that now you have 4 plus 8, and there's 2 here. So 4, 8, and 12, and 2 is 14. Oh, this doesn't work as well. So 4 and 8 is 12 plus 2 is 14. And this will have to be 4. We already have a 4 there. Okay, so like this now, I'm not going to do it. You can see by trial and error, eventually you can get an answer, and it will be this one here. So you had 1, 4. We do have 5 and 8. All right. Oh, I see. Then I had 2 and 3 here. I should have switched those around, and then I would have got my answer. So I was nearly there. I should have tried. I tried 3 and 2. I should have put 2 and 3, and you would have got the answer. You'll see here that the whole 8 numbers are there, and when you check it out, you'll see all the 18, all the 6 sides have got the same sum. All right, so that problem is largely by trial and error. So let's get on to the next problem, which is this one. It's question 3. I find all real solutions to the equation. So you've got an equation here. It's a very funny equation because you've got a base and you've got an index, right? But it's equal to 1. Okay. Now, one of the first things I'm going to say is a to the power of 0 is 1 for any a. The bases are usually positive for any a greater than 0. In these indices, the bases are usually greater than 0. Okay. Now, this is true. I don't know whether you have been exposed to indices, but any number raised to the power of 0 equals 1. And you'll say, but that has got no meaning. Actually, it has. If I just want to explain this, if you take, for instance, if you take a cubed over a squared, and this is a times a times a, and this is a times a is cancelled, and you've got a here. So it turns out that a cubed over a squared is a to the power of 3 minus 2. Because these two will cancel off with those two, and you're left with just that. So in the same way, if you want to extend that idea, a cubed over a cubed is equal to 1, but that's the same as a to the power of 3 minus 3. which is a to the power of 0. You see? So you extend this idea that you subtract the indices and you get that a to the 0 equals 1. So it means that you could have had 5 minus x equal to 0. And there you got x equals 5. So that's the solution. 5 plus 2 is 7. 7 to the 0 is 1. Okay. Now that's 1. Now you could have the... Now let's look at the base, x plus 2. Now that base, to get the answer 1, the base has to be 1. So x plus 2 equals 1. And x is equal to negative 1. Okay, so when you put x equal to negative 1, then this becomes plus 1. And 1 to any power is 1. So that is the second solution. But I just want to be careful here because you can have negative 1 here. You see, negative 1 squared is 1. Right? Or negative 1 to the power of 4 is equal to 1. But negative 1 to the power of 3 is not equal to 1. It's negative 1. So negative 1 to an even power is 1. Negative 1 to an even number is equal to 1. So let's look at x plus 2 equals negative 1. Then what is x? X is negative 3. Right? But I want to see whether 5 minus x, that's the power. That's 5 minus 3. That's 8, and that's even. All right, so x equals negative 3 is the solution. So the answer is, those are the three solutions, negative 1, negative 3, and 5. All right, so that takes me to the... Okay, just to show you, just to check to see whether... Yeah, so this thing does say that there are 3 solutions. So that is what we got. So we are on the safe side. All right, let's now get on to the next problem. Oh, there's some interference there. We go on to question 4. Question 4 says no digit, small writing, hope you can read it. No digit of the positive integer n is prime. Okay. I want to move this, but I can't seem to know how to do it. All right. Okay, let's just do the problem anyway. So you got a positive integer n, and none of its digits is prime. So they all are composite. So the digits are from... Okay, we have to look at the digits which are not prime. 1, by definition, 1 is not a prime. And of course, 0 is also a digit. So the 0 and 1, neither of them are prime. 2 is out, 3 is out, 4 is in, 5 is out, 6 is in, 7 is out, 8 is in, 9 is out. So the numbers are from here. Okay, now However, n is exactly divisible by all the single-digit primes. Okay. Now, what are the single-digit primes? They are starting from 2, 3, 5, and 7. Right? Okay, so your n is divisible by all of them. So these 4 are factors of n. N is divisible by each one of them. All right. Now, observe that they don't have any common factors, right? So therefore, you see, if you've got a number of numbers which don't have a common factor, that means the word for that is that they are co-prime or they are mutually prime. Those are the description for that, but they don't have a common factor, apart from one, of course. One is a factor of everything. Then the product of those numbers is also a multiple. So 2 times 3 times 5 times 7 is 210, right? Is such a number, is a possible value for n. And it turns out that this is really the LCM. The LCM of these 4 numbers is just the product of the whole lot. All right. Now 210, they say, what is the smallest 4-digit number? So 210 doesn't qualify to be a 4-digit number. So I say it's a possible value for n. Now, the all such n are multiples of the LCM. Now, this one is a very important fact, which is not easily mentioned. It's a multiple. Any common multiple of a set of numbers is certainly greater or equal to the lowest common multiple. So the lowest by mean, it means the smallest, right? But I'm going to say more than that. Any common multiple of a set of numbers is a multiple of the lowest common multiple, right? So therefore, the possible values for n are 210, and we take the multiples, 420, 630. I'm multiplying by 3, multiplying by 4, multiplying by 5, multiplying by 6. I'm going to just go on here because, and if you multiply by 7, multiply by 8, you come to that. I'm going to stop there because these are eliminated because they are not 4-digit numbers. Here, no digit is a prime. So this is out. This 5 is here. 2 is here, so that's out. 7 is here, so that's out. But here, this is fine because 6 and 8 are not prime. And we said 1 and 0 are also not prime. So this is the answer. So the answer is 1680. That's the smallest, by the way. Because the next one will be, yeah, this is 210 times 8. The next one will be 210 times 9. So this is the smallest 4-digit number, and so on. Okay, so that takes care of problem number I don't know what. Let's just check to see whether. Right, you can see the answer 1680 right at the bottom. All right, so let's go on to the next problem. Oh, okay. I'm not going to go through the story here, but what goes on? What's happening here is that you have a 3 by 3 cube, as you can see, 3 by 3 cube, and you have a single cube resting in the corner, and the top surface is painted red. What happens now is that this thing is rolled. This thing is rolled to this, and it follows this path here. You keep rolling it. So this path is until you come back, come to this one here. By that time, you would have covered all the squares in which we're looking at. Okay, so the question is, the small cube leaves red paint on all squares on which the red painted side lands. So when this painted side, if it lands on this, the paint there gets stuck onto this, and that becomes red in color. But no other face is painted, so if it falls on any of the other faces, there is no red paint. So let's have a look at this. For a start now, you know that when you roll this thing, you're coming down in this direction, you roll it like this, then the red face is looking here. It's sort of facing, it's facing in this position here, okay? And when you do it one more time, you'll see that that part goes to the bottom. So this part here is red. And it says here that the red paint gets stuck there, right? Because the paint maybe is not dry, and you have very strange. Okay, sorry, I'm having a problem with my pen here. Uh, so I was wanting to get the color red, but I can't seem to get it. Let's just color this thing black then. So it falls here. So that's one of them. And then now you roll it that way, roll it that way, that way, that way, and so on. And each time the red lands on its face is touching this, the color becomes red. Right. Now, I'm not going to do it, but one of the ways of doing this thing here, I saw the solution, so I'm going to give the same solution. This is, if you name these faces, I'm going to call it 1, 4, 5. Now, the face opposite 1 is 6. I don't know whether you know this. It's an interesting fact that the opposite sides of a die, of a dice or die, they always add up to 7. You've got 1 on one side, the 6 on the opposite side. So you have 1, 6, 2, 5, and 3, 4. They are pairs of opposites. So the opposite 5 will be 2 on the other side. Opposite 4, the face which you can't see, is 3. All right, so you can keep track of this thing by seeing what face is actually sitting on this. All right, now you can try that, and the actual thing is here. The solution is given here, right? I didn't do it. but I just believed that these people did the right thing. But we did see the first solution, which was this one. Yeah. Now, when you keep going out like this, you see this 4, you're looking at 4, that 4 falls flat here, right? And then the red is facing us. So when you make it roll once more, that red goes to the bottom, right? So like that, now if you keep rolling it, these are the faces which are on the bottom, and we are looking for the ones. So there's a 1 here, there's a 1 here. Oh, okay, the 1 here. All right, so there are 4 red faces altogether, or 3. The 3 are painted red, right? Because the paint rubs onto the square. Okay, so that's the answer to that. You can see the answer is 3. I went straight to the answer. I didn't draw this. Okay, let's now get on to the next problem. It's question 6. A triangle is divided into strips by drawing equally spaced lines. So that's what I've got here. You got strips here, and they are equally spaced. And then they're colored red and blue. And the question is, if the blue area is 5 square units, what is the red area in square units? Or is it 90 square units? What is the red? Okay, so let me try to draw this in a big diagram. Okay, so you have a single triangle here. Next line, I can repeat this triangle. If I draw a line parallel here, and this way I draw a line parallel, then I've got 4 congruent triangles. They are all exactly the same. So the next area is 5. So this area, the top one is 1. The next area is 3. Now, if you continue to draw the next line, you will see that you got 2 more squares. You draw parallel, parallel. Now, here you see I've got these 3 already there. So I've got an additional two triangles, not squares, triangles. So the next one will be 5 here. And if you go on like this, you will have 7 in the next one, because you keep adding 2 new ones, 9. So you get all the odd numbers, all the odd numbers. And if you look at this, you've got 9 lines here. You've got 4 red and 5 blues. This top one is also a blue. So you got 4 red and 5 blues. That makes 9. And if you count here, you got 1, 2, 3, 4, 5, 6, 7, 8, 9. So the last one ends at 17. So there are, if you break them up into small identical triangles, that way, you know, you got a unit to measure. All right. So this a single triangle has got it's our unit, and we are saying this is one triangle, 3 triangles, 5 triangles, and so on. Okay, now I want to know what the blue is. The blue starts from 1 plus, and yeah, you got 1, 2, 3, 4, 5. You see, you're skipping two lines to get to the next one. And each time you're adding two, so you're actually adding four all the time. So you got the next blue, this one here has got 9 in it. The next blue will have 13. And the last blue, this one here, the 17. 1, 2, 3, 4, 5. And you got 5 numbers. So these are the areas of each of those blue ones. And when you work this thing out, you get 15, 28, 45. So you got 45 blues as 90 square units. 45 triangles, small triangles. Have area 90, so each is 2. So each area is two units. All right. Now the question is, what is the red square in units? Now the red will be, this one here, this will be red here. And we saw that that is 3. And then 2 units down there, it'll be 7, 11, and 15. So those are the ones which are in red. There are 4 of them. And you can see I've ringed 4 of them. And we just want to see what the area of this is. It's 3 plus 7 plus 11 plus 15 plus 10, 21, 36. So it's 36 small triangles. But the question is, what is the red area? So the answer is each triangle has got area 2. Area of red is 36 times 2, which is 72 square units. Okay, you only got 4 red and you got 5 blues. So you can believe that this is 90, this is 72. So the answer is 72. I think, yeah, you're using units here, not centimeters or anything. All right. So the answer is 72. Let's just check to see whether this is indeed the answer. All right, you got 72. But I've divided up into too many squares here. Oh, okay, I've done the whole thing. 1 and 3 and 5 and so on. So I didn't draw all the triangles in the area. So I keep saying squares, but they are really triangles. Okay, now let's get on to the next problem. I don't know what the next problem is. Okay, so we are at question 7. In the right angle triangle ABC below, rectangle DEFB is fitted. Okay, you can see the picture. We don't need to have such a big description. But there is a rectangle here, which is fitted inside this. So all these are 90 degrees. All right, now we are given that AD is 5. You can see it here. And FC is 3. So these two measurements are given. And the question is, find the area X of the rectangle. This X. What's the area of the rectangle? So let's just call them A. Let the sides be A and B. And we don't know those sides. We are given this 5 and 3 only. So the required area is AB. Okay, I'm saying this length is A, and that length is B, and the area of a rectangle is length times breadth. So So we need to find what A times B is. Now I've drawn something here. I want to explain what I've said here. I've got two triangles which have got the same angles. You see, you've got a black, black, small ring, X, X. So these two triangles have got the same angles. Now they are not congruent. Three angles is not a condition for congruency. Because you can see you can have a large triangle and a small triangle having the same angles. So they're certainly not congruent. For congruency, you want all the sides to be equal as well. Okay, but all is not lost. You can actually take ratios of the sides, but one is a blown up version of the other. So if you look at this line here, A, it's opposite black dot. So that's very important. It's opposite black dot. And here, the side opposite black dot, you call these corresponding sides. A and R are corresponding sides because both of them are opposite the same angle. But if you take the ratio, A over R, right? Now you can see the small one, it blew up. It was blown up to get this. So the ratio, the blowing up ratio is A over R. If this is 5 and this is 15, then the ratio is 3. You have to multiply this by 3 to get to that. Okay. So like that, now you take the sides opposite cross. You got cross, you got B here. So which is opposite cross in this one here? It's Q, right? And then finally, you got a degree sign. The sign opposite the degree, we call it C. And what is opposite the degree is P. So there it is. So whenever you got two triangles got the same angles, then you can take these ratios like that. Now, in this picture here, you've got this angle here is equal to this angle here by corresponding angles. This line is parallel, therefore these two are equal. You got the 90 degrees is also repeated in this triangle. So you got 90 degrees. Of course, the third angle will also be automatically equal. The third angle in this triangle here is equal to, but you can see they are corresponding angles. That parallel line, there's an F here. Coming down, coming down. It's not a very decent F. It's got its nose to the ground, but it is an F nonetheless. Okay, so these ratios. So if we do this now, you'll have 5. 5 is opposite curl. Opposite curl is EF. Oh, but EF is A. Then this is a rectangle, and BF is B. So you got 5, which is opposite curl, over what is opposite curl in the small triangle? It's A. Now you can take the other side. I'm not worrying about the hypotenuse now. Here, B is a side in this triangle. So that's opposite dot. And opposite dot in this triangle, this dot here, is FC, which is 3. So using the properties of similar triangles, that the ratios of the sides are the same. It's a very important result. The ratio of the sides of similar sides of similar triangles, that's the word I was looking for, is always going to be the same. But now you see, from this equation, straight away you got AB is equal to 15. Right? Okay. So the next problem will be question 8.